On question number 16, we are given this curve here and a straight line where c is a constant, and we are asked to show that the curve and the line intersect for all values of c. So the straight line that we are given has a variable y-intercept. So the y-intercept could be anything. And what the question is saying is that regardless of what the y-intercept is, show that the line will always intersect the curve. Now this kind of question almost always comes down to finding the discriminant and somehow using the discriminant to show that there are two solutions. And because I know this will involve the discriminant, I'm just going to change this equation very slightly, and instead of x plus c, I'm just going to call it x plus k. And I'm just going to change this part to say show that c and l intersect for all values of k then. Right, so to solve this, what we would do is treat it as if you're trying to find the point of intersection between the line and the curve, and we'll see what that gives us. Right, so to find the point of intersection between the line and the curve, I'm just going to take the equation of the line and substitute it into the curve. So this then becomes x squared minus, instead of y squared, I'm going to have x plus k whole thing squared divided by 2 is equal to 1. Now, what we can then do is we can expand the brackets out, but first we'll multiply everything by 2 so that we have 2x squared minus x plus k whole thing squared, and then multiplying the 2 onto the right hand side as well, that gives us equal to 2. If we then expand the bracket, we're going to have 2x squared minus x squared plus 2kx plus k squared is equal to 2. We'll then expand the bracket. We'll just multiply the minus sign into this and bring all the terms to one side. So 2x squared minus x squared is just x squared. I'm then going to have minus 2kx. So minus 2kx, then minus k squared, and then we'll bring this minus 2 to this side as well. So what we have here then is a quadratic, where a quadratic in terms of x, but where some of the coefficients are in terms of k. So at this point, to show that this quadratic will always have solutions, what we'll then do is consider what the discriminant of this quadratic is. So I want to work out what is b squared minus 4ac. Now, if we consider what each of these letters are on this quadratic we have a is equal to 1 because the coefficient of x squared, b is equal to minus 2k because that's the coefficient of x, and the c term is going to be all of this, so that's going to be minus k squared minus 2. Right, so we'll plug that into the discriminant here. So on some questions it might just say find the range of values of k such that the line intersects the curve. In that case you might say b squared minus 4ac is greater than 0 or greater than or equal to 0. But here we are trying to show that no matter what k is, that the discriminant will always be positive. Right. So we'll substitute these in. So that should give us b squared is going to be minus 2k whole thing squared. So since we are going to square it, we don't really need the minus sign there. I'm then going to have minus 4 times a, which is 1, times by c, which is minus k squared minus 2. Let's then expand the brackets out and simplify this. So this is going to give me 4k squared. Now minus 4 times minus k squared will give me plus 4k squared. Then minus 4 times by minus 2 will give me plus 8. So if I simplify this, we have 8k squared. So this would be 8k squared plus 8. So this is what our discriminant is, right? So the discriminant is 8k squared plus 8. So now we just need to make some kind of convincing argument to show why this discriminant is always greater than 0. Because remember, the conditions for solutions using the discriminant is if b squared minus 4ac is positive, then we always have two solutions for a quadratic. So the way you'd want to explain this, so I've already typed this out here so that just to make things easier. So if we consider this term, k squared, no matter what the value of k is, k squared is always positive. So k squared I said is greater than or equal to 0 for all values of k. And what that means is, therefore, if you take 8k squared, so not just k squared here, if I take 8k squared, that's always going to be greater than or equal to 0. But when we add 8 to it, that is now always going to be greater than 0, because 0 plus 8 will give us at least 8. So we said, therefore, 8k squared plus 8 is greater than 0 for all values of k. So the discriminant is positive for all values of k. And if the discriminant is positive, there will always be two solutions. So the curve and the line will intersect for all values of k.